Hello everybody, today welcome to my mathematical derivation video, and today I'm gonna show you guys how to do the Laplace interpolation and basically the application of Laplace interpolation. So the formula you're seeing on your screen right now is the formula of that, but I didn't write it in the linear algebra way. I write it in the summation and multiplication way. So let's go ahead and explain what the formula is. So the sigma sign stands for the summation. Okay, and so for example, if you have sum of I equal 1, 2, 3 of x square, it would be 1 square plus 2 square plus 3 square, and it will be 14. Okay, and this one stands for multiplication. So for example, if you have multiplication of I equal 1 to 3 of x minus xi. Oh, my apologies, I have to have an I right here. It would be x minus 1 times x minus 2 times x minus 3. Okay, so basically this is our formula, keep it in mind. And now I'm gonna do one function. Okay, so let's say you have f of x equal to x squared. Okay, and then you define your variable. That's the first step. The first step is you have the equation. The second step is you define your variable. So you have x0 equal to 1, x1 equal to 2, and x2 equal to 3. So you have f of x0 is 1 squared is 1, f of x1 is 2 squared is 4, f of x2 is 3 squared and it's 9. Okay, and now I'm gonna write the expression. Okay, so f of x be equal to, first, the first case is, I equal to 0. And what do you have when you have I equal 0? Okay, sorry, let me write lower. Then let me start the boundary, like this boundary is not as intense as the North Korean and South Korean border. Anyway, let's continue. Okay, so I equals 0. So you have f of x0. Follow this one, okay? Follow this one right here. Let me highlight for you guys. Right there. Okay, sounds good. Okay, so f of x0 times the multiplication, it would be x minus x1 times x minus x2. Okay, the reason why it is like that, because you say, well, Justin, where's x? You might ask, where is x minus x0? Okay, and the answer is you're not going to include x minus x0 in this case, because you see this formula right here, I say that j is not I, which means that any j is similar to I must be excluded. So in this case, j equals 0 and I is 0, so j is similar to I, so you have to exclude it. Okay, so you're not going to include x minus x0. Similarly, you have your denominator would be x minus x0. Sorry, my apologize, because it's xi. So xi, this is I is 0. So this is x0 minus x1 times x0 minus x2. Okay, you continue. You have f of x1 times x minus x0 times x minus x2 over x1 minus x0 times x1 minus x2, and then you add f of x2 times x minus x0 times x minus x1, and then the denominator will be x2 minus x0 times x2 minus x1. Okay, and the next step is the step where, you know, most mathematicians will find it very offensive, and that step is plug in a number. So f of x0, you have this is 1 times x minus x1 is x minus, which is x1 would be 2, and now x minus x2, x2 is 3, x minus 3 over x0. What is x0? x0 is 1 minus x1 is 2, and then, you know, x0 is 1, x2 is 3, plus f of x1 is you know, 4 times x minus 1, x minus 3 over x1, which is, can anyone remind me? Oh, I forgot, I'm on YouTube, so no one gonna be around. x1 is gonna be 2, x0 is 1, and x1 minus x2, x1 is 2 minus x2, which is 3, okay, plus f of x2, which is 9 times, you know, x minus x0, which is what is x minus x0? X minus x0, so x minus 1 times x minus 2 over x2. What is our x2? Anyone tell me? Oh, okay, thank you so much. Thank you so much, empty wall. And the answer is 3 minus x1 is 1, and then 3 minus x1. What is x1? 2. Okay, now you're gonna cancel this and see what happened. So this is, you know, x2 times x3, so this is x2 times x3, x minus 2 over x minus 3, and this is negative 2, because this is negative 1, this is negative 1 times, wait, my apologize, this is over 2. Okay, then you plus, this is 1, this is negative 1, so this is negative 4, x minus 1, x minus 3, plus 9, this is 1 times 1 is, so this is 9, x minus 1, x minus 2. Oh, that's really weird, but it's okay. So this is x squared minus 5x plus 6 over 2 minus 4x squared minus 4x plus 3 plus 9x squared minus 3x plus 2. I think there's something wrong with this, actually, because the reason why I say so is I feel like there's something wrong, but you know what, let's continue. Okay, because this is denominator and this is numerator, so I think there's something wrong with it. And what could be wrong with this? Because you see, this is 3 minus 1 is 2. Oh, here we are, there we are. So this is 2 times 1 is 9 over 2. This is supposed to be 9 over 2. My apologize, guys. 9 over 2. Okay, this is 1. Okay, let me write down 1. This is negative 1. Okay, this is 2. This is 1. Negative 1. Negative 2. Yeah, that's why, you know, algebra is always annoying, but hey, f of x fx would be, you know, after you do the consolation, x squared minus 5x x squared over 2 minus 5x over 2 plus 3 minus 4x squared plus 16x minus 12 plus 9 over 2x squared minus 9 over 2 times 3, which is 27 over 2x plus 9. And what is fx? Equal to 3 minus 12 is negative 9. Negative 9 plus 9 is 0, so this is 0. Okay, x squared negative 5 over 2 plus 9 over 2 is 4 over 2, which is 2. And 2 minus, oh, I apologize, wrong coefficient. Negative 5 over 2x plus 16x is 37? Yeah, no, it's actually 27 over 2x, and 27 over 2x minus 27 over 2x. Oh my god, it makes it counter argument. It would be 0, so this term cancel out. And then x squared over 2 minus 4x squared over 2, it would be negative 7 over 2x squared. And negative 7 over 2x squared plus 9 over 2x squared would be 2 over 2x squared, or in other words, x squared. Okay. So what can you say about this? You can say a lot. You see, the goal is you turn to polynomials, right? So at first you have a polynomial. If you want to turn to polynomial, what do you expect it to give you? A polynomial, exact polynomial, right? And yeah, so that's, I hope everyone understand, and I apologize for the onshore mistake. And we will continue next time with more example application. I thank you everyone for their attention, and I wish you have a good night and good day, and depend on wherever, you know, wherever places you are in right now on Earth. And just remember, there's two things. The goal is turn to polynomial and follow this formula, the blue formula right here. You can turn basically everything to polynomial. Okay, have a good day.